Good morning, everyone, and this is Units and Dimension lecture number 7. And this is, since the class has been bifurcated, this is for NEET. So, lecture number 7 for NEET. And let us see what we had discussed in the previous class, because we are going to continue with the same class today. In the previous class, we had seen the third use of dimensional analysis, and that was to find the correctness or to check the correctness of an equation. And we had seen that if the equation is dimensionally correct, it may be correct, as in this case, it is dimensionally correct. It is correct. But if it is dimensionally correct, the equation may also be wrong, as we had seen in this case that the equation was dimensionally correct, but it was actually wrong. The third thing that we had seen was if the equation is dimensionally wrong, the equation has to be wrong. A dimensionally wrong equation cannot be a correct equation at all because it is dimensionally wrong. Now, many a time in NEET, to be very specific, you will get questions, and some questions may not be from dimensional analysis, but you can find their answers. You can find their answers using dimensional analysis. They may not be. There will be one or two questions strictly based on dimensional analysis. There may be one or two or three or maybe four questions that you can solve using this concept of dimensional analysis. They will not be direct questions. They would be, as I say, indirect questions. So pay attention on this particular use of dimensional analysis, because this particular use will be beneficial in questions which may not be even a question of dimensional analysis. So let us first understand how we are going to use it. And to understand that, what I am going to do is I am going to give you a question or an example number 1. You are given an equation f is equal to mv square by r. Have you seen this equation before, beta? You're given an equation f is equal to mv square by r. Have you seen this equation before, anyone? Raise hands. Have you seen this equation before? Okay, no one has seen this equation, it seems. Anyways, let me tell you what are the terms in this equation, and you may help me. What will f stand for? Any idea?
Force.
F will stand for force, so you know it, so I'll not write it. Great. Remember, sometimes whatever we use for one particular term, every time even that term comes, we will be using it for the same thing. What will m stand for here? What does m stand for here? Any idea? F stands for force, yes. What does m stand for? It can stand for anything.
Mass.
Yes, but here it stands for mass. That is correct. M stands for mass. I'll write it so that you don't get confused. M stands for mass. This is given to you. F stands for force. What will V stand for?
Velocity.
Velocity.
Well done. We are doing great. What does R stand for?
Radius.
Radius. Radius is basically distance, nothing else. Now, you have to tell me, if this equation is given to you, what do you think about the equation in terms of dimensional analysis? Is this equation correct? Is this equation definitely correct? Is this equation maybe correct? Or this equation is wrong? So you tell me, using dimension analysis, can this equation be correct or not? Or is it wrong? Do you think it is correct? How will you find out whether this equation which I have written right here is correct or is wrong? So I'll give you time to solve it. And how do you do it? We always, if you remember, we had written some 4 or 5 points about dimensions, and in the entire chapter we are using those 5 points. So I'll give you time to tell me, using the knowledge that you have gained, is what do you think about this equation? Now I can see that all of you are going back and looking at probably what we have done previously. And as I said, beta, if you have to look back in the class, that means you have not studied while you have come here. And that is not a good sign, because that is going to get us into trouble. Remember, the problem with physics is that every other class, and I'm talking about till the entirety of this 11th standard, if you do not remember what we had done in the previous class, if you do not come to the class without reading the previous class, it would be very difficult for you to do anything in this class. Anyways, the question is given and I can see everyone is looking at the whiteboard and doing nothing. That will not serve any purpose. Even if you don't remember anything, you can go back and see and at least try this question. If you don't try and if you keep sitting like this, things are not going to get into your head automatically, right? So please try and solve this question. Even if you have to take help from the notes, take it. Since you have not read it, take the help, but try. If you don't try, you will not be able to solve question in the examination hall. Remember, out of 45 questions that we are expecting in the exam, or 50 questions, at least 15 to 20 questions would be straightforward. If you know it, you know it. Only 25 questions, 25-30 questions would be somewhat numerical. Out of that 25-30 questions, 15 to 20 would be damn simple. Only 4 or 5 questions would be a bit difficult. But if you don't try and if you sit like this in the class, well, this is not Tare Zameen Pe, we are not, you are not Amir Khan who sits in the class like this. Please try. Anyone with an answer? What do you think about the equation? Is it correct? Wrong? Maybe correct, maybe wrong, definitely wrong. What is the answer? Or do you want me to solve it? Two options. No one? Are you trying? Yes or no? Please raise your hand if you are trying to solve the question. Are you trying? Okay. Boys sitting at the back are trying. Girls sitting in the front are also trying. See, I can. As I told you, I am omnipotent and omnipresent, so I can see all of you. What you are doing. You might hide, but don't hide. Even if you don't want to solve the question, be in the front and don't solve the question. Okay. Anyone? How are you going to find out this question? Okay. Since you probably need some inspiration, so I'll try to give you that inspiration. How are you going to solve it? Well, we just need to check dimension. And the first thing that we read about dimension was, if the equation is dimensionally correct, dimension on left hand side and dimension on right hand side should match. Yes or no? Yes or no?
Yes.
That's it. That is what we are going to check here. What is the dimension of force?
MLT minus 2.
Yes, MLT minus 2. This is the dimension of force, so I write it here. What is the dimension of M? M is mass, so the dimension has to be M only. Yes or no? Do we understand this? Okay. What is the dimension of V?
LT minus 1.
Minus 1.
Well done. Now we are talking. Well done. We need a bit of inspiration. I understand this. So LT minus 1, it is square, so I square it. What is the dimension of R?
L.
L. Well done. We just check the dimension on the left hand side and the right hand side. And now I'm not going to solve it from here. Find out if the dimensions are matching. Are they same on both sides? Dimension of LHS and dimension of RHS, are they same? Yes or no? This means yes. This means no. Yes. The dimensions, my dear friend, are matching. The dimension on this side and dimension on this side, they are matching. That means, now we have to understand what it means. This means that this equation is dimensionally correct. Are we there on the same class, on the same page? This equation is dimensionally correct. Now, there are two things that are possible. Two things that are possible. This equation can be actually correct. This equation can be actually correct, or this equation may also be wrong. This equation may be wrong as well. Now, it all depends on whether there is any other term, which is a number, which is multiplied over here. And I can tell you, because I know that there is no number multiplied here, or the number multiplied here is 1. Therefore, this is actually an equation which is actually correct as well. Now, how do I know this? How do I know this? Because I know that this is correct. To find out whether an equation is actually correct or not, you have to actually know the equation. This is basically the equation of something known as centripetal force. Have you heard this term, centripetal? This is the equation of centripetal force, which is experienced by a particle when that particle is moving in a circular path. Since I know this is the correct equation, I can mark the blue thing that this equation is dimensionally correct, and from my knowledge I also know that this is actually correct. Do we understand this? How do we check? See, we are just using simple things that we have studied in the first class that are being used here to solve questions. Has everyone noted this down? Can I move on to the next question, please? Okay, here comes the next one, and I hope that all of my kids would be doing this question. Question number 2. Time period of a pendulum. Time period of a pendulum is given by this equation, pi root over L by G. Given you this equation, time period of a pendulum is given by this equation. Now you have to tell me, my dear friends, whether this is may be correct, may be wrong, or this is wrong and you cannot do anything about it. Your time starts now, and I hope all of you do it. I give you time. Please solve it. The only way we are going to learn or understand our mistakes is by solving the question. If we do not solve the question, we would not be understanding what mistakes we are going to make in the examination hall. This is the time where you can make mistakes and understand and learn from those. Examination hall is not the place to make mistakes. This is the time and place to make mistakes. So solve it now. Yes, my dear friends. Anyone? No one? Not good, not good, not good, not good. I'll wait. I'm a patient person. I'll wait patiently for your answers. And I know that you are going to solve it. Give you 2 minutes. Take your time. So, what we have here is T is the time period of the pendulum, L is the length of the pendulum, and G is acceleration due to gravity. Now you got to tell me, what do you think about this equation? Is this equation correct? Maybe correct, maybe wrong, definitely wrong, maybe right, maybe wrong. Which is the correct option? Again, you don't have to do anything extraordinary. You just have to do simple things correctly.
Correct.
This equation is correct.
Sir.
Maybe correct or definitely correct?
Definitely correct.
This equation is definitely correct and that is definitely wrong. That is not the right answer. Unless and until you know the value of time period, and this is not the exact answer, this is not definitely correct. This falls in the category of may be correct or may be wrong. How are we supposed to do this? T is time period. I'm going to check the dimension. Dimension of time period is capital T. Do we understand this? Yes or no? Let us look on the other side. What is the dimension of pi? Pi is a number. I can't have dimension of a number, so this goes away.
Cancel.
Yeah, so I've cancelled it. That means it does not have any dimension. Do we understand this? I'm not cancelled it. It does not have any dimension. I'm not going to write the dimension. Okay. What is the dimension of L? L is length, so the dimension is L. Divided by, what is the dimension of G? G is acceleration. G is acceleration. What is the dimension of acceleration, my dear
Meter
friend?
per second square.
I'm talking about dimension, beta. Again, if I talk about dimension and you tell me the unit, that means you are going on the
ML
wrong.
T minus 2.
M0 L1 T minus 2.
Yes, yes. If I ask you the correct question, I should get the correct answer. Remember that. If you give me something wrong, that is not correct. Then I have to put this root. So I put the root as well. And then I check the dimension on left hand side and I check the dimension on right hand side. And I will leave that for you. The dimension on the left hand side and the dimension on right hand side, are they same? Are they matching? Yes or no? Are the dimensions matching? Left hand
Yes,
side
sir.
and right hand side. Yes. This dimension and this dimension are definitely matching. Therefore, I can safely say that this equation is dimensionally correct. Do we understand this? Yes or no?
Yes,
Now,
sir.
two things can happen. This can be actually correct or this can be wrong. Which among these? For that, you have to know the actual formula of time period of a pendulum. And my dear friends, the actual correct formula is T is equal to 2 pi root over L by G. I had not written 2. The constant term, the number 2 was missing. Therefore, this equation is not correct. It is dimensionally correct, but it falls in the wrong category. So what do you say if you don't know the correct equation? You can say that, sir, this equation is definitely correct, but I do not know whether it is actually correct or wrong, but dimensionally it is correct. It may be correct, it may be wrong. Here I am going to tell you the correct answer. Time period is 2 pi root over L by G. Therefore, this equation is dimensionally correct, but it is not actually correct. Do we understand this? Can I have raise hands from everyone that we understand this? Okay. That is great. I hope everyone is noting this down. Simple points here you will have to remember. And with these simple points, you will be able to score very heavily in the examination hall. Let me move on to the next question. Are we ready for the next question? Okay. Here comes question number 3 for you guys. Now, question number 3, let me talk about this. And which question should I give? Okay, I'll give you this. Pressure exerted on a body is equal to M into A by X. Yes, beta? Pressure exerted on a body by something is given by this formula. P stands for pressure. I have already. Let me finish the question, beta. If you have any doubt, you can ask it. M stands for mass. A stands for acceleration. And your X stands for the distance. Can you tell me about this equation? What do you get about this equation? Is it correct? Maybe correct, definitely correct, maybe wrong, or definitely wrong. We'll take step by step, small steps, and the small steps will lead us to our eventual result. I give you time, 1 minute, to give me the answer for this one, my dear friends. And to understand this entire concept of how you are going to find out about an equation using simple concept of dimension analysis. And I'm sure 1 or 2 questions directly will come from this chapter, and at least 2 or 3 or maybe 4 questions in your paper you can do by this concept. That is why this is a very important topic. Just my dear friends, do I see light at the other end of the tunnel? I'm on this side. Do I see light on that side? Yes or no?
Yes.
Yes, light is there. So what about the equation? Correct, maybe wrong, definitely wrong. What is the option?
Definitely wrong.
This is definitely wrong, and that is a definitely correct answer. Well done. So we are on the right track. This is a definitely wrong equation, and that is a definitely correct answer. And how do we get it? Well, we do not have to actually dig the tunnel, because tunnel is already there. We just have to go past it. P stands for pressure. Let me write the dimensions of pressure here. What is the dimension of pressure?
M1.
M1L minus 1T minus 2.
You don't have to say M1. You can simply say M. Okay, M, L,
minus 2.
L minus 1 or L1? L minus 1, T minus 2. Do we remember this, bacha? You don't have to. You should remember this. This should be equal to, here M is mass. So mass has a dimension of M. A is acceleration. So it has a dimension of LT minus 2. X is distance. So it has dimension of L.
L.
Now you check the dimension on left hand side and the dimension on right hand side. Are they matching, my dear friends? And kids and bachas? Are they matching? This is not matching here. Yes or no?
Yes.
That means this equation is dimensionally wrong.
Wrong.
If this equation is dimensionally wrong, my dear friends, it cannot be correct. Do we understand this? Yes or no? No, yes. Can I have some reason from anyone that we understand this? Simple concept. Well done. The next question comes. I hope everyone has written this. The next question comes on your screen. Right about now. And this is question number 4. Let us see if we can solve this question. P is given by 3 FV square by pi into T square X. Now, I hope you know what are the terms. What is P here?
Pressure.
Pressure.
F. F.
Force.
V.
Velocity.
T.
Time.
X.
Distance.
3 and pi. 3 and pi are numbers. What you are, sir? You have gone mad, sir. You don't know 3 and pi are numbers, sir. Okay, sir. So, sir, this question now comes to you, sir. I mean, what do you think about this equation? Definitely correct. Maybe correct, maybe wrong, sir. I am not sure, sir. Oh, definitely wrong, sir. Let us see, sir. What answer we get, sir?
Definitely wrong, sir.
Definitely wrong, sir. Well done, sir. And that is the correct answer, sir. This is a definitely wrong equation, sir. But let me give everyone a fair chance. Everyone a fair chance of finding out whether this is correct or not. Everyone should get a fair chance of solving a question, my dear friends. Some of us may solve it very fast, but some of us, like me, may take some time because I'm not that sharp. So please give me time so that I can also come on the same level as the other students who have solved it faster. So what is happening here? Okay, sir. Anyone with their answer, sir? Ready, sir? Shall I solve it, sir? P is pressure. The dimension is ml minus 1,
2 minus
Minus
2.
2.
minus 2. These are numbers, so we don't have to worry about their dimension. I have not crossed them. The only thing is, they do not have any dimension, and I am not only concerned about dimension. F, my dear gentlemen, my dear friends. Oops, wrong color. I am very particular about colors. F is force. What is it?
MLT minus 2.
So it is
MLT minus 2.
LT minus 2. As you can see, with time, all these terms and all these dimensions are coming to us very quickly. V is velocity.
LT minus 1.
LT minus 1.
Well done. Now we are talking.
Sir.
Divided by T is time.
T minus 1.
T2, sir.
T is time, my dear friend. T square. T square. X
L.
is L. Now I check the dimension on the left hand side and the dimension on the right hand side. I will not do it. I want my kids to do it. Are they same? This side, this side. Are they same?
No, sir.
No, sir. And
Sir.
that is correct, sir. Dimension on this side is not same as dimension on the other side. And therefore, this equation has to be definitely wrong.
Wrong.
Please raise your hands, all those students who were able to do this on your own. Only 2 girls, no boys. Shame on you, boys. Well, boys are always way behind girls. Sad day. Very sad. Anyways, everyone gets a second chance. I call it chance to redeem yourself. Students are like those cash vouchers. If one time the cash voucher doesn't work, you always get a second chance to redeem it. So this is your chance for redemption. And remember, as I told you, these questions are direct questions. Direct questions from units and dimension. But there may be some question which you have no idea about. And still you can solve it using dimension analysis. And to give you an example of one such question, this is one such question which is probably not a direct question from this chapter, but this is an indirect one. As I told you, there could be some questions which you can solve using dimension analysis. You may not know anything about that topic as well. Here comes a question. Oops, do you see it? Yes, we see it now. A boomerang has a mass m. Boomerang. You are all YouTube guys, so you must have seen videos of boomerang. A boomerang has a mass of m, surface area of a, radius of curvature, which is radius as r, and it's moving with a velocity v in air of density rho. So everything is given. M is mass, A is area, R is the radius, and rho is the density. Resistive force acting on that boomerang, which of the following formula is correct? For the resistive force acting on that boomerang. Oops. Now, I'll give you 2 minutes to think about this and tell me how you are going to do this. We don't know anything about boomerang, sir. What is density, sir? Surface area, sir. What is all this? But even without knowing anything about a boomerang or the force, we have not studied force, or you have not told us what is force. Now, how can I find out the formula? C. C is the correct answer, sir. That is great. So now we are talking. C is correct. But for the rest of us who are not so quick in answering, how do we understand this? How do we get this? Yes. Bacha, tell me, how did you get the answer? You had no idea what is force. How did you get the answer? Hey, you got the answer. What was it? Tukka? कौन बनेगा करोड़पति? Sir, अक्कर वक्कर बम्बे वो 80-90 पूरे. So when I got the answer, I had no idea. Huh? It was a question without any risk. You know, we have already won 2 lakh rupees and this is a free question. Give it a shot. How did you get the answer? Yes, bacha. Huh? You got the answer, but you don't know how to get. How did you get it?
F is equal to 2p r square a.
How did you get it? I'm not worried about the answer. Your answer may be different.
ml minus 3.
How did you get the answer? That is what I'm asking. You are saying ml minus 3. Remember, beta, the thing that I'm least worried is your answers. The thing that I'm most worried is how you get them.
By using dimensional formula, sir.
Yes, by using dimensional formula. Now, just have a look at all these options. Look at the first option, the option A. Now, if you look at the terms, it has rho, V, A, and R square. If I look at the second, it has, forget about the number, it has rho, V square, A, and R. So this is different from the yellow one, because in yellow one, we had R square and V was single. Here we had V square and R was single. Look at the third one. Here we had V square, but there is no R. Look at the fourth one. You had both V square and R square. That means all these 4 options are dimensionally different. Yes or no? All these 4 options are dimensionally different because in some we have 1 V and 1 R. In some we have 1 V and R square. In some we have V square and R. In the other one we had only V square and no R. That means all of these options are dimensionally different, only that option can be correct which is dimensionally correct. So I just have to check the dimensions of these questions, these options. Whatever dimensions matches the dimension of force. What is the dimension of force, my dear friend? The dimension of force, because we have to find out the resistive force. So it must have dimension of force. The dimension of force, oops, wrong color. I'm very particular about colors. Why do I make color mistake? The dimension of force is MLT minus 2. That is what I should remember. I just need to check the dimension of all these quantities and find out which one is matching the dimension of force. I'll do one for you. Let us check this yellow one, this first one. Let us check the dimension of this one. How we are going to check it? We know on the left hand side we have MLT minus 2. Let us look at on the right hand side what we have. 2 does not have any dimension, so let me take it out. Then I go for dimension of rho. Rho is density. The dimension of density, my dear friends, is ML minus 3. Yes or no? Do we understand this?
Yes, sir.
Sir.
This is the dimension of density. I put the dimension of density over here, multiplied by the dimension of velocity. This is LT minus 1.
Minus 1 whole square.
Option number 1, it is only V beta. So I will just only put V, not V square. Then it is A is area. So it has dimension of L square divided by R square, which has the dimension of L ka square. Now I can check the dimension on right hand side with the dimension on left hand side. Are they matching? This dimension is not matching. That therefore this option has to be wrong. Yes or no? Do we understand this?
Yes, sir.
Because the dimension is not matching. Similarly, you can match the dimensions of all these options and you will get the right answer. I know the right answer is C. So let us check the dimension of C here. I hope everyone is following me. Yes or no?
Yes, sir.
There's no point of me checking the dimension of B and T because that's just a waste of time. So I'll just check the dimension of C because I know the answer is C. How do I know it? Just by experience. Let us check the dimension of this option C. 2. No dimension taken out. Dimension of rho is ML minus 3. I put it here. Dimension of V square is L
P minus 1.
minus 1 ka square. Dimension of area is L square. And then I check the dimension on right hand side with the dimension of left hand side. Are they matching, my dear friends?
Yes, sir.
They are matching, and therefore the only option which will match will be my option number C, and therefore C becomes my correct answer. That is how solve a question which may not be a direct question of dimension, which may be an indirect question of dimension. Do we understand this? Yes or no?
Yes, sir.
Can I give you one question more?
Yes, sir.
Okay. This is how questions are framed in an exam. Please don't get bamboozled by this question. Oh, I don't know, sir. I don't know anything about the formula, sir. But you can, if you understand the topic, you can solve the question. Here comes a question for all of you. And I sincerely hope that all of you are able to do it. Time period of a satellite. Now you don't know what is a satellite, what is the time period of a satellite. Time period of a satellite moving around a planet of radius r is given by which of the following options? The first option is time period is 2 pi root over G by R. What is small g here? Arey, what is small g here?
Acceleration due to gravity.
Nah, it is not gravity, huh? This is acceleration due to gravity. Okay. Oh. See, in Josh, I did wrong. Okay. 2 pi root over GR. Option C. T is 2 pi root over R by G. Option number D. T is 2 pi root over 1 by GR. Now you know nothing about the time periods. You have not read the satellite wala chapter, which is gravitation, which is way ahead. Still, can you do it? Looking at the option. Your time starts now. And I hope you would be able to give me a satisfactory reply. Remember, I'm not worried about the answer. No, I'm not worried about the answer. I'm worried how you are going to solve it. That's it. Because if you solve it correctly, you will invariably land up with the correct answer. The time has already started, my dear friends. And now you have understood the concept of how I'm going to see things. I look at the options, see, which is, do you think is a correct answer? And if you are lucky, the same question may come in your exam. Because this is a very popular question on time period of a satellite. I'm waiting. Someone will rise. Just like Pushpa Part 2, the rise is going to come. Someone will rise and take the world by storm. Who is going to rise? Apart from Allu Arjun, is going to rise in coming months. Yes. Yes. No one is rising. Shame. Okay, you might be checking the dimensions of the options. Okay, I'll give you time. वैसे ही I am a patient person. Oops. No one has an answer. Shall I do it for you then, my dear friends?
C.
P is correct. Well done. So my aspirations has been fulfilled that you are able to do a question without even knowing anything about the question of a time period of a satellite. You could do it just by what we have done in today's class. Again, my concern is not the answer. My concern is how we are going to do it. And the simple way of doing it is by checking dimensions. Yes or no? No, yes. So let us go on and check the dimension of the first part. Remember, the yellow one. Remember, 2 pi does not have any dimension, so 2 pi just jumps out. On the left hand side, I have the dimension of t time is equal to root over. On the right hand side, g is acceleration due to gravity. It has a dimension of lt minus 2 divided by r is radius. It has a dimension of l. Are the dimension on both sides matching?
No, sir.
No, sir. You can see, sir. So definitely this option is wrong, sir. Now you can go on solving all these options. There's no point of me doing it. This option will also be wrong. This option will also be wrong. Let us look at the blue option. Since I know which is the correct answer, I have that knowledge and liberty. Now let us check the dimension of the blue one. Well, I know that is the correct answer. How do I know it? Well, I know it. T is equal to 2 pi does not have any dimension. Don't be worried about that. Root over R. Root over R is L
LT minus 2.
divided by LT
LT
minus
minus
2. Are the two dimensions matching? And the correct answer
Yes.
yes, sir, they are matching. Oops, wrong dabba. Here dabba. Anyways, that means the correct option has to be option C. Yes or no? No, yes.
Yes.
Yes, sir.
Now see. If you could have remembered things, you may have just skipped and told me the answer, and that is why I say the power of remembering and the power of smart hard work. We had done a similar question just 10 minutes before. Do you remember it? See, I'll show you. This one, my dear friends, time period of a pendulum. And we had found out that it should be root over L by G. L was length and G was acceleration due to gravity. That gives the correct dimension. Yes or no? Look at this dimension, L by G, root over L by G. Time period should have always this dimension, root over L by G. Now, if you could have recollected this, because we have already done this, there was no point of doing this entire exercise. You could have just looked, what is the dimension of R? It is L. The dimension of G is same as G. So the correct option is simply C, sir. I don't need to solve the entire question, sir. I know the answer beforehand, sir. So do you understand what is the meaning of smart work? Can I have raised hands from everyone? That is the reason I gave you the same question. That if you could have recollected, sir, time period of pendulum, root over L by G. G, I just see root over L by G where it is coming. It is coming in third option, sir. That is the answer, sir. What are you doing, sir? Making fun of me, sir. I know that, sir. So that is what you remember, beta. If you do one thing once, you remember it. Remember it so that you can save some precious time in the examination hall, and that time may help you in solving one or two more questions. And one or two more question means if you are getting a private college, you might get a semi-private or semi-government one. If you're getting a semi-government one, you might get a government one. If you're getting government one, you might get the best one of the premier colleges in India. If you are getting one of the premier colleges in India, you might land up at AIMS. If you're landing up at AIMS, you might land up at AIMS Delhi. Two questions will make that much of difference. Even one question will make that much of difference. Okay, that is your use number 3 to check the correctness of an equation. I hope I have given you sufficient examples to make my point clear. We will be doing more examples, but not now, not here, because if I do more examples now, it will have terms that we have not read till now. So I will move on ahead with the other or use number 4. The fourth use of dimension analysis. The first use was it is used to convert from one unit to other. The second use was it was used to find out the dimensions of unknown quantities. The third one was we can use it to check the correctness of an equation. What is the fourth one? To find, sometimes I may call it rough, or sometimes I may call it empirical, or sometimes may I call it possible, depending on how the question is asked, to find a rough or empirical or possible formula for a physical quantity. Now, I may ask you, have you heard this term empirical in chemistry? Empirical formula in chemistry? No, yes, yes, no. This is yes, and this is definitely no. Yes, no. Neither yes, neither no. That is not the correct answer. Yes, you have heard about empirical formula. You might have heard about empirical formula or general formula, you call it, for a hydrocarbon CnH2n plus 1, CnH2n, CnH2n minus 1, minus 2. You put the value of n, you get the, if you know the value of n, you get the actual formula. Similar to what we are going to do. Now, sometimes a question may come where what? Now, this is also similar to what we have done previously, where we do not know the actual formula, but using dimension analysis, we can guess what may be the formula. We may not know the actual answer, but we may guess the answer. So that is known as the empirical formula or rough formula or a possible formula for force or any physical quantity. Now, the best way to understand this is by an example. So I'll give you an example. So how this example is made, and the simplest possible ways, I will make this diagram, and that is the best example that we give. Do you understand what is this? Arey, what is this? My drawing is bad, but it is not that bad. I can draw a straight line and a gunda. What is this? Arey?
Pendulum, sir.
Yeah. God exists. This is a pendulum. Simple pendulum, we call it. We'll understand different types of pendulum: conical pendulum, physical pendulum, torsional pendulum. Right now, it's simple pendulum. Now, when you give it a tuck, 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 dung, 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 you will be doing it in your physics practical. We calculate the time period of this pendulum. Now, I am doing that same experiment. Time period of a pendulum. Time period of a pendulum, which is a drawing here. Time period of a pendulum. Now, what all quantities do you think it depends on? Time period of a pendulum depends on. What are the quantities that you think it will depend on? It will depend on the length of the pendulum, yes or no?
Yes, sir.
Now, longer the pendulum, it might have a longer time period. I guess so. It might depend on the mass of this bob that you see here. Heavier bob may create a lesser time period or something like that. And it may depend on G. Do you understand what is this G, my dear friends?
Yes, sir.
This G is
Acceleration due to the gravity.
Yes. Don't forget it. This is not gravity. This is not gravitation. What I want to ask you, find a possible formula of force. Force. Find a possible formula. What could be possible of capital T? This capital T is your time period. Now, you have conducted some experiments, and this is what you get from this experiment. That time period, you might guess pendulum. What is there in a pendulum? It has a string, so length of the string. It has a mass. It has a bob at the end of this. Without bob, the pendulum doesn't work. It might depend on the mass of the block. And if I understand, because this pendulum will have some force, gravity will come, acceleration due to gravity will come. It depends on G. Now, with just these information, common sense, can you calculate a possible formula for time period of a pendulum? Well, you can do it using dimensional analysis. How you are going to do this? The time is over. So we will be discussing this in the next class. How we are going to do it, what all types of formulae we can derive, what all types of formulae we cannot derive, that will be under a separate heading limitations. It might look like with dimensional analysis, we can do anything in this universe, not everything. There's limitations to this. So we will see those limitations as well. We'll be solving this question and 2 or 3 more examples based on this question, and we will try to wind up your units and dimension by the next or the next to next class by this week. That is my target. I hope you have enjoyed today's class. Well,
Sir.
on that note, I will wind up today's class, and I'll see you in the next class. Take care and have a nice day.